In this video, I want to answer the question, what is a union? And not only do I want to answer the question, but I want to justify why I'm even bringing the question up in the course here, okay? First of all, a union allows two variables to share the same memory. And yes, you heard right and you read right. Two variables, x and y, share the same memory location and they overwrite each other, okay? Now I know what you're thinking. What could possibly go wrong with this kind of scenario? And of course the answer is, thanks to your sarcastic question, a lot can go wrong with this. We can very easily lose control of this, overwrite our data with the wrong data, create all kind of logic errors in our program and so forth. All right, and so what's the reason that people would do this? Well, let's take a little history lesson here, okay? And before I do that, the reason I'm even bringing this whole sordid affair of a union up is because you're still going to see these. C++ has been around a long time, and a lot of the old timers wrote this way. Why? Well, it dates back to the days when we all used to have to walk to the school in the snow, uphill both ways, and all those sad stories that we heard. Because back in those days, boys and girls, our computers only had, 64K of memory. Remember the Commodore 64, the Texas Instruments TI-99-4A, and all those kinds of things only had 64K of memory. Well, if you're coding in that environment, you had better really do everything you can to conserve memory, or you're going to have a problem. And if you have a memory leak with only 64K of memory, you've really got problems, okay? So when you're writing code for those types of environments with computers that only had 64K, you had to do everything you could to conserve memory. So obviously we're not there anymore. We now have gigabytes of RAM on our machines. Why would we want to mess with these things? Well, it allows two variables to require half as much memory space, all right? And that's not that big a deal anymore with all the memory we have, but one can utilize the memory space when the other one's finished with it without having to initialize a variable and all that. So you can eke out just a little performance gain there. So that may be one reason you would use it now. The next one is if you're not sure what data type will be required, since two different data types can share the same memory, right? Notice at the top I said two variables. Now I'm kind of adding to the plot here. Two different data type variables can share that same memory space. Then again, I can save a little bit of overhead by just simply plugging data in there without having to create a whole new type. Okay, so here's the bottom line though. You can use dynamic memory allocation now since we've got gigabytes of memory available to us, and it's usually a better solution. Notice the word usually. You could come across instances where you need to use a union, and I just wanted you to be aware of this. You can use the new keyword when you create your objects, and it will place them on the heap. Now if you use the new keyword, you have created dynamic memory allocation. Everybody's got their own memory address. Everybody comes into existence. Everybody's using pointers. Everybody's happy. The only thing, if you use that new keyword, you need to use a destructor when you're through with that object, or it will never come off the heap. And in essence, you're leaking memory, tying up memory you can't get back to and free up, and memory's leaking away from availability to everything else on the computer. Now, when you've got a couple of gigabytes of RAM available, this usually isn't that big of a problem. However, it can become one. All right. So what does a union look like? And I want you to see this because, again, a lot of us old-timers are still in our old habits, and we'll still use unions because we've always used them. Or you may just open up old code that you're having to enhance or rewrite or correct or whatever, and you may see these unions in there. Well, this is what one looks like. You'll see the keyword union, and then you will create the union. It's called long and short. And notice you'll kind of lay it out here. It's got an X, a variable in there called X. It's a data type of long, a variable of Y with a data type of short. And then, much like a class, we can just give it an instance name out here, okay? Or you could just create this as an instance, union X of the type both long and short. But that's what you end up with, and then to access it, you just call unionx.x or unionx.y. Now, if I set unionx.x equal to 2, it overwrites whatever in y or x, and then if I set y equal to 3, it overwrites it, and my union x value is going to be the y, and it's equal to 2. All right, so play with this if you would like. I just wanted you to be aware of it. Stay away from it generally. It can be problematic, but it is a tool. You need to know about it. You could see it in old code, and I just wanted to bring it to your attention. I'm not going to do any examples on it or anything. Just want you to be aware of it and know what you're looking at when and if you see it out there. The struct is another object that you'll see out there in C++, and I wanted to point it out to you here in the video so you'll understand what it is, and I also wanted to give a little warning. But first of all, let's talk about what a struct is. A struct is actually a variation on the idea of a class. Now, in C++, understand that when we're talking about a struct, we're talking about really the same identical thing as a class, except that all the members are public by default. Now, you've noticed in other videos in this course, when we're working with classes, that cat class that I've used as in a lot of examples, that we have to mark our variables and our functions as public because they're private by default. In a struct, everything's public by default. You'll have to mark it private, okay? Now, is that any big reason to use a struct? Maybe not, okay? But these things are created and used just like classes. And so the question becomes, well, then why don't you use a class? Well, whenever I teach about C++, if it's a live situation, and I ask what's the difference between a struct and a class, the .NET programmers, and I am one, okay, I'm twice the center that they are, okay, so the C++ and the VB programmers will inevitably throw their hands up and say, well, a struct is allocated on the stack and a class is allocated on the heap. A class is a reference object, a reference type, and a struct is a value type in .NET parlance. And that is true in .NET. It's not true in C++, okay? So understand that in C++ you don't get the same efficiency of using a struct as opposed to a class like you do in the .NET world, okay? Now, let me give you a little history. So if that's the case, if a struct's the same thing as a class except for this public and private situation with the members in the class, the variables and the functions, then what's the big deal? How did we get here? Well, the struct originated in the C language, and then Windows was written in C, and the struct was used quite a bit in that programming. Now, as a result, the idea of the struct kind of got burned into the programmer world, if you will, and so you hear a lot of old timers that they're talking about. So the struct was out there. Windows kind of established it. They get handled different in the .NET programming languages. They got thrown into C++ because more or less as a backward compatibility thing to C. All right, so there's no real magic here, but these things are used, and you will see them out there. And some people will just use a struct as opposed to using a class because everything that's going to be in there is going to be public, and they just use a struct. It makes it easier, and everybody's okay. All right, but you're going to see these things. You can use them. I just wanted you to be aware of them, and we'll do a little example in a separate movie and let you see what one looks like in code. Now let's take a look at actually using a struct in code. Now I want to show you this example because you will still see a lot of these out there. And if you'll actually go out and do a little digging around the internet, you'll find that people still argue and fight and debate about these things quite a bit. The people coming from the .NET world have a very definite understanding of how structs work, and oftentimes they tend to try to transfer that directly over into C++, and it just doesn't work that way, okay? So let's take a look at creating a struct. Now I've created a project here. Let me get this out of the way. Struct Example. You will see this out there in your work files, and you'll have a lot of this code already built for you. Now let's take a look here. If I want to create a struct, I just use the keyword struct, and I can call it pet. I'll get away from cat. How about that? And then I'm just going to give myself some space and come down and close it out just like I would a class, okay? So far we look just like a class, right? Well, what I'm going to do is I am going to just copy some things in here so you don't have to watch me type this stuff. And we'll just put it in right here. And you'll notice that what I've copied in, I've created a variable called name. It's a data type of string. I've created a variable called weight. It's a data type of integer. Same for age. It's an integer. And then I've put a string in here called enoch, and I don't know why I put that in there. I will just take that out. And then I have a function here that returns a string. The function is called inoculate, and when you call it, it just creates a variable called x, loads it up with inoculated, and returns it out. All right. Now, anything look different from a class there to you? And of course, the simple word is, at first glance, no. All right, but when I use it, you will see what's different. Notice if I create a type pet, and the name of it, I'm instantiating a object called Fluffy of the type pet. All right, notice I don't have any trouble using it. Okay, now what's missing? The word public up here. This thing is public by default, and the only thing that I can do is, if I don't want it to be public, I can set it to be private. All right, and then when I try to call Fluffy, then I'm going to get a problem at some point. It's going to say, hey, wait a minute, you can't do that. And so now it's telling me, hey, wait a minute, that is inaccessible. All right. And so that's the biggest deal, is these things are public by default. And you will see them quite a bit, and they'll do all kind of things. And then, of course, we can come down here, and instead of type that, I will copy it in. But these things are all over the place. And again, the biggest thing that I want to protect you from is from yourself. And let's just create this and run it. Because if you're coming from a .NET world, you will assume things about what's happening with these and why you should use a struct. And you think you're creating a value type variable and it's very efficient and all that. And in reality, you're not doing anything really different than a class other than this public-private default. So if I go out into my projects that I just built and I go find my struct example, hold down my shift, right click on debug, open command window here, and just type Struct Example, you can see that inoculated was returned. Okay, so it simply reached up into Fluffy inoculate. Fluffy is an instance of pet, ran inoculate, it returned that back to me through X, and everything's cool. That's what a struct looks like. Everything I've shown you, I could replace this with class, then I'd have to put the public designator in there, and it would all be the same. Okay, so struct, class, almost the same thing in the C++ world.